Greetings to everybody. In this video, I'm going to be solving problem number 2 of the end of semester exams in Real Analysis 2 for the guys in the Department of Civil Engineering at the Faculty of Engineering and Technology under the University of Boya. So the problem 2 reads, evaluate the improper integral, the integral from 0 to 1 of 1 on the square root of x dx, and it was allocated for 3 points. Okay, so we are trying to evaluate the improper integral from with bounds 0 and 1, and our integrand is 1 on the square root of x. So if we let our f of x, that's the integrand, to be equal to 1 on the square root of x, let's try to find its domain of definition. It is defined on the set from 0 to positive infinity, 0 being excluded. I believe everybody can find the domain of definition of a rational function. Okay, now why is it called an improper integral? Because there is a certain point that is part of the limit of integration that is not found in the domain of definition. So we generally refer to them as improper integrals. Here we can see that the point is 0. We see in the domain of definition, 0 is excluded, but as a bound, 0 is a bound, so it is referred to as an improper integral. So for improper integrals, we now use the limit definition, because at the end you are not going to be substituting 0, because 0 is not in the domain of definition of the integrand. So you're going to be taking the limit as a certain parameter tends to that 0. But remember, we are in the interval 0 to positive infinity, so the limit as the parameter will be tending to 0 will be specifically 0 from above and not 0 from below, or not just 0, because in this interval, if I am going to 0, I am definitely greater than 0, so I'll be taking the limit as my parameter t is tending to 0 from above. Of now the integral from t to 1, I replace the 0 now with the t, from t to 1 of 1 on the square root of x dx. So for all improper integrals, we use their limit definition. I've explained to you what an improper integral is. So the integral from 0 to 1 on the square root of x dx will be the limit as t tends to 0 of the integral from t to 1 of 1 over the square root of x is the same as x raised to the power negative half. Now I'm integrating with respect to x. Now from the fundamental, we know the integral from x to the n of dx is x to the n plus 1 plus a constant of integration, because I've taken the indefinite case without limits of integration. And remember, n is different from negative 1, because if n is equal to negative 1, this will not exist, and we'll be tending to integrate x to the negative 1, which is 1 on x. That's why we have a standard integral, which is the natural logarithm, the Napoleon logarithm of the absolute value of x if you integrate 1 on x. So that's why generally in this rule, n is different from negative 1. You can even see the denominator is n plus 1. For this to exist, then the denominator should not be 0. Okay, so for n equal to negative half, as we have seen here, we can just fit in negative half here. We have x to the negative half plus 1, which is half, divided by negative half plus 1, which is half, then plus my constant of integration. Now when I introduce it now to my improper integral, which is definite, the constant of integration cancels out, and I just introduce my limits at the bounds. So I have my integral to be the limit as t tends to 0. 1 on half is 2. Now x raised to the power half. Now I can remove the 2 outside because it's a constant, and now introduce my upper limits and my lower limits. Fitting the upper limit is just a square root of 1, which is 1, minus the lower limit is a square root of t. Now as t tends to 0 from above, I can distribute the 2 inside here, and I get the limit of 2 minus 2, the square root of t. So from there, I can take the limit of the first part, the limit of 2 as t tends to 0 from above is 2, because it's a constant, properties of limits. Next, the limit as t tends to 0 of 2, the square root of t. Now as t tends to 0 from above, the square root of t tends to 0. So I have everything here tending to 2 times 0, which is 0. So by so doing, the integral from 0 to 1 on the square root of x dx is equal to 2. So that is the final answer of the improper integral, which is definite. Alright, so I hope you love the video. If you love the video, like the video, share with your friends, subscribe to the channel, also comment on the comment section if you face any difficulty. See you later and thanks for your time.